So for number 31, we're using the nearest integer function. It just takes decimals and rounds it to an integer. Some conventions round 2.5s upwards, some round downwards. In this case, actually we'll see. Actually, no, we won't see because we're not getting any close to 0.5s. So the integer function. Let's just understand what the heck that is. So if I'm gonna say that 2.5 is gonna round up because I feel like most people are familiar with that. So if I plug in 0 to x, the nearest integer to 0 is 0. So great, that's awesome. If I plug in 1, the nearest integer to 1 is 1. So out comes a 1. But if I plug in like a point 0.2, something over here, 0.2, the nearest integer is, so this is 0.2. This would be 1. This would be 1. If I plug in 0.2, the nearest integer would be me rounding down to 0. So in fact, all the way up until 0.5, we'll say I'm going to round upwards. When I get to 0.5, the nearest integer, that's not 0.5, that's minus 5. 0.5. When I get to 0.5, the nearest integer I'm going to say is 1, and that's just based on convention. So it's like a step function. And then backwards as well. If I go to like negative, let's do negative 1, so that means here's negative 0.5. Well, if I get to negative 0.5, I'm going to round down to negative 1. That's the nearest integer. So here, it would look like this. And then this goes up here this way, and then a little bit, and then open. And so it looks like a step function. And it continues on. But we don't really care about that. We're just approaching 0. We're approaching 0 from the right side. So this goes to 0. Easy. In fact, the same thing happens for number 33, because we're still approaching something over here on both sides of, what is it, the limit as x approaches 0.01. That's going to round down to 0 again. So yeah, if we just look at the graph, then we get 0. So for number 33, the answer is 0 as well.